Hello again. Nothing ended up growing from this reaction, so it's been about an hour since it happened. So there isn't any water vapor coming off, and I did want to show you the process on how to clean this because right now that is still probably very acidic. And for safety, you want to make sure you're being appropriate with that. So, one, to prove that it's still acidic, I have a base. And bases are things that counteract with acids to produce water. A very popular base is baking soda. So if we see a hiss here, which I'm pretty sure we will, we are going to know for a fact that we are going to be having still acid here. You know, surprisingly enough, it's not hissing. So that's a really good thing. So again, we might not show this video if there's nothing interesting to happen. So if you're still tuning in and this video is up, something interesting does happen. So I'm going to add water, and I'm going to add baking soda to this. And I apologize holding this with one hand, so I'm just going to dash with the box a little bit. And we can see that's at least still acidic. So one of the things we can do to make sure that we're dealing with something safe is we have something called universal indicator. Now, universal indicator, I don't know how well you could tell, it is a green solution, and it literally, based on the rainbow, tells you whether or not something is acidic or basic. Acids normally go red, bases go purple, and everything in the rainbow in between. So I'm going to add some of this. I've already watered it down to show the green color a little bit. I'm just going to spill some around. And you can see it's definitely still acidic based on that red color. See if I can show a little here. I don't know if you can tell by the outside. It's definitely red. Oh, it's red. So I'm going to just throw this around. And we're going to try to get this to be as green as possible. For example, I wanted to, again, prove that bases can go purple. And you can see they're going towards the blue range. So what I'm going to do is I'm going to add some water. And again, this has been doing its thing and sitting around for over an hour. You can see the other disc that came off. This is, again, once clean carbon. And you can see how just red this is. You know, this is still definitely acidic. Definitely not something we want to throw away. We want to make sure we're being safe. And you can start to see more of the colors as I add baking soda. Green is right in the middle, so we like that. We love that we see green. And again, we're primarily focusing on what I see coming off this. And again, the reason we're doing this is because I don't want to dispose of this if there's still acid on it. As you can see, there's a lot of little porous holes where the acid could still be stuck in the middle. And I don't want to handle this or have anyone else handle this if it's not as safe as possible. So with a little bit of universal indicator, again, I just added maybe 3-4 milliliters and then added some water. We're able to figure out, based on this green color, that we're definitely safer with this than we were before. The fact that this is still bubbling tells me that there's still acid in the center that we're working its way through, and I can see that it is a little more yellow here than over there, which tells me that it's still acidic. Gonna submerge this. Bring it over here. And again, just because, I'm going to add the whole box of baking soda. Again, I will get more for the chemistry department, don't worry. And again, it is kind of getting in between. And again, I'm just going to keep doing this until, honestly, this stops bubbling. And that's how you can properly dispose of something like this that has a large acidified content.